Alright guys, so here is our next problem dealing with modeling real-world data. So recall our last video where we were determining what type of function we were dealing with. So we were given data and they wanted us to determine, okay, is this going to be linear, quadratic, exponential, square root? And I gave you a list of rules that you can use to determine that. Okay, so it may be useful to go back to that video and just refresh yourself. Because we're going to be doing the same thing here, except this time I don't have the rules written. Okay, so let's go ahead and read this problem, and then we're going to talk about how we are going to set this up. It says a scientist is monitoring the population size of deer released into a state park. Write a function to model the given data. Alright, so before we go ahead and create a function here, we need to know what we're dealing with. Is this going to be linear, quadratic, exponential, square root? Okay, so we have to go back to our rules and we have to identify our function here, okay? So what I'm going to do is just make a quick list. So we have linear, then we have quadratic, I'm going to abbreviate here, exponential, okay, and in a different color, I'm going to go ahead and write square root. Okay, so linear, quadratic, and exponential, okay, we can kind of group these together because they're going to have something in common. Right? So if you have a linear, quadratic, or exponential, they're all going to have evenly spaced x values. Okay? Square root, however, will have evenly spaced y values. Okay? So going back to linear, quadratic, and exponential, we know that they all are going to have evenly spaced x values. However, with linear, okay, it's going to have a constant first difference. Okay? For quadratic, it's going to have a constant second difference. Okay? And for exponential, it's going to have a constant ratio. And again, this is going to be all between the y values. All right? So that constant first difference, that constant second difference, and that constant ratio is going to be between the y values. Okay? For square root, we said that it's going to have evenly spaced y values, but it's going to have a constant second difference between the x values. Okay, so kind of a lot to take in there, but again, we'll just keep hammering it in. So what we're going to do here, we need to determine what we're dealing with. So I'm just going to go right in order here. I'm going to start with linear and work my way down. Okay, so we know linear, it's going to have evenly spaced x values, which it does, right? Here's my x, here's my y, so time is my x, deer is my y. So we're going to test the first difference here. So I'm just going to write first, and this is for first difference, and we're doing it between the y values. So 70 minus 35 is going to be 35. Okay, 140 minus 70 is 70. 280 minus 140, well, that's going to be 140. So notice here, it is not a constant first difference. Those are all different values. So we can already write off that, okay, this is not going to be linear, right? It's not linear. Okay, let's try the second difference. Okay, and if these are all going to be constant, then it will be a quadratic. If not, we keep moving on. Okay, so when you do the second difference, just know you're going to use what the values you got for your first difference. So you're not going back up here and using these, you're using these new values. So you're doing 70 minus 35, which is going to be 35, and then 140 minus 70, which is going to be 70. So again, we don't have a constant second difference. These are different values, right? So it's not going to be quadratic either. All right? So let's test exponential. All right? Again, exponential is going to have evenly spaced x values as well, which we have, so we're good there. However, we're going to test the ratio between our y values. I'm going to see if it's going to be a constant. All right? So we're going to do 70 divided by 35. And that will be 2. 140 divided by 70, that will be 2. 280 divided by 140, and again, that will be 2. So we have a constant ratio between our y values. It's going to be 2, 2, and 2. So this tells us that we are dealing with an exponential function, all right? So this function is going to be exponential. And what we can do now is, right, we can finish this off in our graphing calculator now that we know that we're dealing with an exponential function. All right, so I'm going to go ahead, pull up my calculator, and show you how we can generate an exponential function using this data, okay? All right, guys, so here we are on the calculator. All right, we have it turned on. And what we're going to do here is go to the Stat button, so S-T-A-T. So we're going to go ahead and click that. And we're going to hit Edit. So we're going to hit Enter. And we're brought to this table here. Now this L1, L2, that's going to represent your X and Y values. So L1 is actually your X values. L2 will be your Y values. So I'm going to go ahead and just plug that data, okay, right off the whiteboard. So I know that my X values are going to be 1, 2, 3, and 4. Okay, and now I'm just going to go ahead and plug in my Y values. So I'm going to move over, and I have 35, 70, 140, and 280. Okay. What we're going to do here is just hit second quit. All right. And we're going to go back to the Stat button. And now we're going to go over to Calc. So we'll move over to Calc. And now you're going to look for the type of function that you're dealing with. That's why we did this test. We know that we're dealing with an exponential. So we're not going to do a linear regression, a quadratic regression, a cubic regression, right? We're looking for exponential regression, all right? And that's going to be right here, EXP, okay? That's exponential regression. So we're going to click that one, all right, because that's what we're dealing with. And we're going to hit Enter again. And there is our equation, all right? So there is our equation for our exponential function, right? So we're going to go ahead and plug that in just as we see it. So notice A, right, it's going to be 17.5, B is 2, and then we just have our X. So I'm going to go to my Y equals, okay? I'm going to go to, so I'm going to type in 17.5, that's my A, right? My B was 2, and then we just have our X. Okay. And we're just going to go ahead and graph this guy. So hit graph. And notice there is our graph. Now this is pretty cool because we can use this as a predictor, right? This is a model that we can actually use to kind of gauge the future, right? And predict. And what we can do here is just kind of test it out. So if we go to second calc and we go to value, let's plug in some values for X. Like what happens when the time is 4 years? So if we type in 4, oh, we have 280 deer, right? Well, let's go a little further. Let's go to second calc and let's type 5. What happens after 5 years? Oh, we'll have 560, right? And you can keep going with this. You can also use the table. So if you go to second table, right, you bring up your table, and you can also do it this way, right? This is a little more convenient, right? So again, X is your years and Y is your deer population, right? We can see the exponential growth here. And that's pretty much it, okay? So that's how we create a function using real world data, right? And that's it.